Okay, in this question, we have a guess at what an average income is, and we have a known variance, which means we also know the standard deviation. And it's a little bit different than what we typically are doing with calculating the confidence interval. Here, we need to figure out how large of a sample size, how big does n have to be in order to get this particular level of confidence with this error margin here. So this is really just picking away at a formula. And what I'm going to do is, here's the frequently asked question page. The formula sheet for Hawks is here, or you could go to it directly. And if we go to chapter 10, right here is the confidence interval for the population mean. So the way this works is you're trying to estimate the population average, and you start off with the sample average. This x bar is your sample average, and then you have plus or minus this what's called the error margin here. So as it turns out, in this particular problem, they give us the error margin, and then we can figure this out from the variance, and we can figure this out also from the level of confidence that they're looking for. So let's take a look at how we do that. Going back to this question here, and let me put this on a little scrap of paper. Okay, so again, this little portion of the formula is called the error margin. So even though there's not a direct formula for the error margin, since this plus or minus thing is called the error margin, we can set up this equation right here. So 0.59, which is that error margin they're giving us, equals the critical z-value that we'll look at in just a second, times this standard deviation would just be the variance, the square root of this variance. So let's go ahead and get that, or 4. So that's going to be 11.2. So equals, go ahead and put that, 11.2. And then this n is what we're going to solve for, so we need to leave that open. And the last thing that we need to get is this critical value here. There's a couple different, we could actually get it from the standard normal table, but since we have these tables available to us, let's just grab that. Actually, let's get this one here. What I meant is we could get it from these tables right here, but we can actually get a shortcut here. So this z alpha divided by 2 with a 0.85, so that's what this particular one you would need to adjust if it's a different level of confidence. But that would be 1.44 is what we're looking at right there, 1.44. So if I pull up this again, I'm going to get 1.44. And now it's not trivial. You have to dive back into your algebra a little bit here. What you want to do is multiply both sides by the square root of n. So you'd have square root of n equals, and then you're going to divide both sides by the 0.59. So you're going to have these two numbers multiplied by each other divided by 0.59. So let's do that real quick. 1.44 times 11.2, and then we're going to divide that by 0.59 to get 27 point, let's say 336. 27.336, and that's the square root of n. So if we square both sides, we're going to get the value of n here. So I'm just going to take that number, I'm going to square it, and that will give me 747, but it says round up to the next integer, so that's going to give me 748 in my case, and I will submit that.